Hello everybody, Earth Otherwise here to continue our journey through game programming in C++ start to finish by Eric Yazwa. Next on the road to rendering text is the implementation of color or tint in our images. We'll need this because we're going to be using the same code that Ben uses for turning a TrueType font into readable text. We won't be going into the details of creating a character sheet from a TTF file and then getting the characters from the sheet and putting them on the screen in a readable way. If necessary, we can learn that later. For now, we want to get the letters on the screen as fast as possible, and that requires color for this particular code. There's a side benefit of us now being able to tint our sprites any color that we want as well. So what we need to do is pop into our multisprite.h file, and above our vertex structure, we're going to create a color RGB8 structure. Struct color RGBA8. It will contain two separate constructors. So color RGBA8, and then like this. Our little list. Two of those. Just Control-C that. Stick the curly brackets on the end. Paste. Oh, accidentally hit Control-F there. And it will contain 4 GLU bytes. RGBA. Now for this, we want to construct them all at 255. And for this one, we want to get GLU byte, R, GLU byte, G, all 4, and then we want to put them in the normal way. And once we've done that, I believe that's everything we need to do in here. We just need to handle the .cpp file. In here, we need to add another one of these. We need to copy that, paste. We need to add a new vertex attrib array, which will be 2. It's number 2. It has 4 components. They are not float components. They are unsigned bytes. Normalize them. We do want them normalized. We want them to be between 0 and 1. They are in vertex, and they are not called this. They are called mcolor, which reminds me we didn't actually do that here in vertex. Pop down, color, RGBA8, mcolor. There we are. Now this will be correct, and now we need to make sure that this actually has somewhere to go. So we open up our shaders, texture vert, texture frag. So here in TextureVert, we're going to change a few things. We are going to put this GL position all on one line. So here, instead of XY, we are going to do vec4, and then vertex position 0.0 and 1.0. That's just so that we're doing it all on one line rather than on 3 separate lines. In here, we need our new layout. Location equals 2. In vec4, because 4 components, and vertex color will be the name of the game. And we're just going to take that color and we're going to output it. Vec4 capital color, and down here capital color is equal to vertex color, because we need to use it in the fragment shader, not here in the vertex shader. So here we just get in our color. So in vec4 color, and then instead of here we do vec4 texture color is equal to that, and then our actual color is equal to texture color times color. So essentially we're just multiplying our normalized color by texture color. So it will be between 0 and 1. Each of the 4 bits of this will be between 0 and 1. Each of the 4 bits of this will be between 0 to 1. And if it's 1, there will be no change. If it's less than 1, then it will go down or up depending. Now that we've done that, we need to pop into main. And these vertexes are no longer done properly. We need to add a color to them. But to indicate that we need to add a color to them, we need to pop back into the .h file and add a color here. COL, color RGB8, color, and here, M color, color. Boop. Simple as that. And now in main, it will actually tell us, yep, that we are no longer doing it properly. So, as well as our 2 positions and our 2 UVs, we now need an otherwise color. And this will just be 255, 255, 255, 255, because 255 is the highest a GLU byte can go. Copy that, and pop it in to both of these. And these lines are getting a bit unwieldy, but unless your screen isn't very big, it shouldn't be too much of a problem. Though a lot of programmers prefer that their lines don't get longer than 80 characters. I forget why, but I don't bother putting limits on myself like that. I don't need to. And, we can just refactor it later, because we're going to be probably rewriting a goodly amount of this later at some point. So, if we save everything and build it, everything should be fine. Everything succeeded, so now we just pop this open, and we should see absolutely no change. It appears that we... Invalid layout qualifier. We got a compiler error in our vertex. I think I spelt something incorrectly. Vertex color, vertex position, UV color out. We misspelled, well, not me, just me. We misspelled location as collation. Anyways, as I was saying, there should be no change. No change! So let's do a change. So let's pop into main, and let's RGB, let's make red a lot more prominent. Let's go 100 for the rest of them. Well, not the alpha, because that would make it more transparent, and we don't need that. And there we are. We now have a brown apple. So that is all we needed for color. With our color in place, all we need now is a camera in order to change our perspective so that we can actually be able to see the text that we'll be writing. So, one more tutorial, and then we'll put text on the screen. And in between, we'll just happen to move into 3D space, because why the hell not? Anyways, this has been Earth Otherwise. Thank you for watching.